So this section we're going to start off looking at mutually exclusive events. Mutually exclusive means you have two things or two events that cannot occur at the same time. Okay, so they have no outcomes in common. So if we were talking about randomly picking a student, and let's say we were looking at their grade level, the grade level could be freshman, sophomore, junior, senior. They have no outcomes in common, so they would be mutually exclusive if, um, like for instance, picking a junior and senior. Those are mutually exclusive because you cannot be a junior and a senior at the same time. Let's say you roll a die. You cannot roll the number 2 and the number 4 at the same time. So those are mutually exclusive. You toss a coin. Your two events are heads or tail. Can they happen at the same time? No, they can't. So those are mutually exclusive events. So those are some examples of what it means to be mutually exclusive. We have a couple of um, addition rules that come with that, and that's the reason why mutually exclusive understanding what it is important, because there are two separate formulas depending on whether or not they're mutually exclusive. So the first one is, oh, sorry, a couple new symbols as well. So the first symbol is what looks like a U, and I think that looks like a U because it stands for the union. So the union is when you have A or B. Okay, for instance, you roll a die, and we ask what's the probability of getting a 2 or a 4. So you ask yourself, all right, can a 2 or a 4, 2 and a 4 happen at the same time? No, you cannot roll a 2 and a 4 at the same time. So because you cannot get both of those at the same time on one roll, they're mutually exclusive. So to figure out the probability of rolling a 2 or a 4 would simply be adding up the probability of rolling a 2 plus the probability of rolling a 4. All right. Now what if we get to something that is not mutually exclusive? For instance, we say, what's the probability of being female um, or being a junior in high school? So you ask yourself, can you be a female and can you be a junior at the same time? Yes, you can. So we have a little bit different formula for that. Formula for that is the probability of A plus the probability of B, so that'd be the probability of being a female plus the probability of being a junior minus the probability of being a female and a junior. So that's what this upside down U stands for, is the intersection, which is and. I got something on the next slide that kind of explains that a little bit better. So we have two circles here, and this is what's called a Venn diagram. Oops. So I'm going to have to get out of this to change it up. So think of these circles as two separate events, all right? Event A and event B. So if these were mutually exclusive events, they would look like this. Event A would be like rolling a die and getting a 2. And event B would be rolling a die and getting a 4. Okay? So whatever this probability is and whatever this probability are two separate probabilities. Okay? They don't have anything to do with each other. However, I don't want that. If we look at these and we'll get that out of the way. So if, for instance, we look at these and we say these are two separate events, right? Probability of A, probability of B. What if probability this event A was being a female and this event B was being a junior in high school? Those both could happen at the same time. So what it would look like is something more like this. You would have some overlapping, meaning these would be females, everything in the blue. These would be juniors, everything in the green. and there would be a little bit or some overlapping, meaning females that are juniors. All these over here that aren't in the overlapping section, all these over here would be females that are not juniors. So female freshmen, female sophomores, female seniors. Okay. Over here, these would be all the juniors that are not female. So these would be male juniors. And anything in here would be things that overlap. So these would be females that are also juniors. So you have mutually exclusive, looks like this, no overlapping. Not mutually exclusive, looks like this. So that's the reason for this formula. You add up the probability of A plus probability of B, but you minus the probability of the intersection. You minus this section in here. The reason you have to minus it is because you've added it twice. You've added the section in the blue and the section in the green, and you've counted those people twice. So you have to subtract that intersection. Okay? All right. So here we are. Determine which events are mutually exclusive and which are not when a single die is rolled. So what's the probability of getting an odd number and getting an even number? Are those mutually exclusive or not? Can those happen at the same time? If you roll one die, can you get an odd number and an even number at the same time? So if we look at the sample spaces, odd numbers are 1, 3, and 5. Even numbers are 2, 4, and 6. Are there any that are the same? No. So because of that, they are mutually exclusive. Determine which events are mutually exclusive in the following: getting a 3 and getting an odd number. So if we look at what's the sample space for getting a 3, it's only one number getting a 3. What's the sample space for getting an odd number? It's 1, 3, or 5. Are there any of these that are the same? Yes, obviously 3 and 3. So those are not mutually exclusive events. How about getting an odd number and getting a number less than 4? So what's the sample space for getting an odd number? You have 1, 3, and 5. How about numbers less than 4? You have 1, 2, and 3. Anything overlap? Yep, the 3 and the 3. So those are not mutually exclusive. How about getting a number greater than 4 and getting a number less than 4? Numbers greater than 4 are 5 and 6. Less than 4 are 1, 2, and 3. None of them overlap. Therefore, they are mutually exclusive. Okay, so the formulas. In a political rally, there are 20 Republicans, 13 Democrats, 6 Independents. If you picked a random person, what's the probability that he or she is either Democrat or Republican? Okay, so you have 20 Republicans, 13 Democrats, 6 Independents. What's the probability of picking a Democrat or a Republican? Can you pick a Democrat and a Republican at the same time? No. So those are mutually exclusive. Therefore, you will be using this formula. You just take the probability of A plus the probability of B. So we go back to it. You take the probability of being a Democrat plus the probability of being a Republican. Democrats are 13 out of a total of 20. 13, that's 33. 6, that's 39. So 13 out of 39. Probability of being a Republican is 20 out of 39 right there. Add them up, you get 33 out of 39, which reduces to 11/13. Okay, we got another example. In a hospital unit, there are 8 nurses, 5 physicians, 7 nurses, 3 physicians are females. So that leaves you with what? 1 nurse and 2 physicians that are males. If a staff person is selected, find the probability that the subject is a nurse or a male. So the question is, are they mutually exclusive or not? Can you be a nurse and a male at the same time? And yes, you can. So therefore, we use our second formula. Probability of A plus the probability of B minus the probability of A and B. So what's the probability of the first one, being a nurse? We have 8 nurses out of 8 plus 5, that's 13. 8 out of 13. Okay. So they break it down. We have 8 out of 13 right here. What's the probability of being a male? We have, like we said, 1 nurse and 2 physicians right there. So that's 3 out of 13. And then we subtract anything that overlaps. So any nurses that are males. There is only 1 of those. So that's why we subtract the 1. So 8 plus 3 is 11 minus 1 is 10. So your probability of being a nurse or a male is 10 out of 13. And that wraps this video up.